Okay, Assalamualaikum and good day. My name is Wan Hafi bin Mazlan, metric flight number MH21006, and I will be presenting on the introduction for the lab title Air Conditioning System for Hybrid Vehicle. So, first off, what is air conditioning system for hybrid vehicles? Air conditioning system is an essential part of maintaining the comfort of passengers in a vehicle, specifically an energy efficient air conditioning system that is used in a hybrid vehicle. So for the second one is the application of air conditioning provides thermal comfort for passengers in various weather conditions and ensure that the vehicle is at a proper temperature regulation to avoid components from being damaged. Some of the key features of air conditioning system in hybrid vehicles is that it uses electrically driven compressors that is energy efficient and extends battery life along with reducing strain on the hybrid system. Uses heat pump technology that can perform both heating and cooling using the same system, reducing energy consumption. Regenerative cooling to improve air conditioning performance, and lastly, smart climate control systems that adjust automatically based on passenger presence, weather conditions, and driving mode. Okay, that is all for the introduction. I will pass it on to my team member. Thank you.
Hi, I'm talking about the theory of ecosystem. So the basic theory of ecosystem is works on the vapor compression refrigerant cycle. It will use a refrigerant such as R134A, which is we can find common in our vehicle. This refrigerant will absorb and release heat. The heat will be extracted from the cabin air and expelled outside, providing a cooling effect. So the main component of the aircon system is first thing is compressor, which is the heart of the aircon system. The compressor will increase the pressure and temperature of the refrigerant gas. Second, we have condenser act as a heat exchanger, releasing heat absorbed from the cabin into outside air. Third, accumulator to filter out moisture and contaminant from the refrigerant. Fourth, expansion valve to regulate the flow of the refrigerant into evaporator. Evaporator, the function of the evaporator is absorb heat from the cabin and cooling it before release it again. So the last thing is blower to circulate cool air through the air vent. Now let's we talk about the working principle of air conditioning system. The principle of the aircon system have four stages, which is compression stage, heat dissipation stage, expansion stage, and lastly cooling stage. I will explain about all the stage in the aircon system. First one, the compression stage. The compression stage is when the compressor compress the refrigerant, increase its temperature and pressure. The hot, high pressure refrigerant gas move to the condenser. Second stage, heat dissipation stage. This stage will works when the condenser cools the refrigerant by transferring heat to the outside air. The refrigerant turns into a high pressure liquid. Third stage is the expansion stage. The expansion valve lowers the pressure of the liquid refrigerant. This rapid expansion cools the refrigerant significantly. Last stage is the cooling stage. The cool, low pressure refrigerant enters the evaporator. It's absorbed heat from the cabin air, cooling it before the blower fan circulate it. The refrigerant turns back into the low pressure gas and return to the compressor to repeat this cycle. This cycle is the continuous loop closed cycle.
Assalamualaikum, my name is Ajay Maika Biraja Badrul Hisham, Matric ID MH21009. For the methodology, first component selection and system design, we need to consider a different air conditioning components such as compressor, condenser, expansion valve and evaporator. Also use of control sensor to monitor the performance. And then the experimental setup and testing was conducted with an air conditioning test rig which include components such as compressor, condenser, expansion valve and evaporator. For the data collection procedure, first we need to record the initial ambient temperature and pressure, and then we need to turn on the air conditioning system and allow it to stabilize, and then setting the timer 15 minutes before collect data. Measure and record temperature, pressure, mass flow rate and compressor current at different points, and then we repeat the process at different compressor speed. For the performance analysis, the effect of different compressor speed 2000 rpm, 3500 rpm and 5000 rpm on cooling capacity, energy consumption and efficiency was analyzed. And then the graphical comparison we use to assess the system performance under varying condition. For the conclusion, the optimal compressor speed was determined to maximize the efficiency and cooling performance.
Now let's we talk about the result of our lab experiment. So for this experiment we use the different speed of the compressor which is at 2000 rpm, 3500 rpm, 5000 rpm to analyze its performance in terms of cooling capacity, compressor works, and efficiency. So I will talk about the first speed, which is 2000 rpm. With this speed, we can see that the highest temperature, which is 62.4 at the beginning of the cooling cycle at the T2, and the lowest temperature we get is 12.6 degrees Celsius. So the pressure of the refrigerant in the system is 207 to 79 kilopascal and 637 kilopascal for the high pressure. So the compressor current is 17.3 ampere. So the second speed, 3500 rpm. The highest temperature is 67.5 degrees Celsius and the lowest is 9.3 degrees Celsius at T6. The pressure of the refrigerant in the system is 196 for the lower pressure and 752 for the high pressure. The compressor current is 34.3 ampere. Last speed 5000 rpm. At this speed we can get at this beginning of the speed we get 77.3 degrees Celsius at T2 and the lowest is 8.5 degrees Celsius at T6. The pressure of the refrigerant is 158 kilopascal at the low pressure and 890 kilopascal at the high pressure side. The compressor current is 48.4 ampere.
All right. Next, we move to the discussion. Okay. You can see before from the previous slide, we can see the result that we obtained from the experiment. Okay, so now we want to discuss of the result. Okay, so based on the result, we calculate the COP. We calculate the coefficient of performance or COP to get the COP result. And then you can see the graph that show the decreasing trend from the 2000 rpm, 3500 rpm, and 5000 rpm, which shows the decreasing the value of the COP. Okay, the cooling capacity is the of the air conditioning system is improved as the system rises because the output temperature drops. However, because of the greater compressor duty, this improvement comes with a higher energy consumption. The pressure differential between the system's high pressure and low pressure sides increase with the greater RPM, which raises the energy requirement even more. As seen by the drop of COP values, higher RPM considerably lower overall system efficiency, even when the marginally increase the cooling capacity. Operating at the 2000 RPM is therefore the ideal setting for the system as it offers the optimum balance between energy efficiency and the result. Okay, that's all for the COP discussion.
Okay, my name is Muhammad Fauzi bin Ahmad Sufyan. My metric number is MH21014. So next we go to lastly we go to the conclusion. Okay, for the optimal performance at 2000 rpm, achieving the highest COP of 30.21, balancing efficiency and cooling. Higher RPMs increase cooling but significantly raise energy consumption. At 5000 rpm, COP drops to 6.23, showing reduced efficiency despite better cooling. High pressure differential at increased speeds negatively impact battery life and fuel efficiency in hybrid vehicle. So to conclude, 2000 rpm is recommended for optimal energy efficiency and cooling, enhancing vehicle sustainability and passenger comfort. That's all from us. Thank you.